When someone tells me I'm building an AI product, the first question I gotta ask is I stop them and I go, hold on, which AI product are you building? That's kind of like it's someone saying, I'm an engineer. But what kind of an engineer are you? Are you like a rocket engineer, a civil engineer, a software engineer? What are you? So this is not an academic question. It really does matter because the type of AI that you choose, that actually determines how you're going to frame the problem, what data you can collect, and which evals you're actually going to be used to see if your product works. My name is Nazir. Over the last 8 years, I've shipped products across most of these AI generations that we just talked about, both in a startup and in for large enterprises. So currently a data science manager at a US telco. Now, I also teach GenAI and Agentic AI courses for product leaders and engineers like yourself. So in this episode, we're going to talk about 6 generations of AI. Actually, we're going to talk about 5 generations. Once we get to the 6th generation, you're going to see why you don't care about them. Okay, let's start with the first wave. Legacy AI. Think of it as starting back in the 1990s, very popular, late 1980s, 1990s. Legacy AI, also known as expert systems, lots of if-then statements. It's basically hard-coded rules. You work with the domain expert. So think of IBM's Deep Blue that actually beat Garry Kasparov, the world grand chess champion in the late 1990s. Very expensive. I think the system was about $100 million or so. Graph models fall under this bucket, legacy AI. They're still used, but for the most part, we've actually moved away from legacy AI. Even Tesla, at one point, they had hard-coded rules for the self-driving mechanism. Let's move on to the second wave, classical AI, also known as machine learning. This is probabilistic AI. So these are the kinds of algorithms you've probably heard about, very popular in the 2000s, 2010s. And guess what? It's still popular today. I'm still using this 2020s at the telco that I'm in. So if you have structured data like tabular data, if data that fits in a spreadsheet, lots and lots of rows and lots of columns, well, guess what? That's going to be useful for machine learning algorithms like linear regression, logistic regression, XGBoost, decision trees, random forest, you name it. The popular algorithms that you've heard of, it's going to be useful there. Now, this is great when you have structured data. But let's move on. Let's talk about the third wave, neural AI. This actually took off with 2012 with AlexNet. So neural AI, think of SLM, small language models, the BERT, the Elmos, the Ernies, the AlexNets, the LeNets, the CNNs, RNNs, convolutional neural nets, and so on. Very popular back in from 2012 onwards. By 2018, you were working with transformer models. So this is for unstructured text. So unstructured data, so typically text. And then GenAI took off in, I think it was around October 2022. That was the rise of GenAI. And what took neural AI, the SLMs, into the LLM bucket, the small language model, to the large language models and multimodal language models is basically reinforcement learning with human feedback. It's a technique, but the bottom line is same architecture, but now you're talking about Gen AI or generative AI that is actually being used for ChatGPT, Anthropic, and so on. And Tesla, guess what? They've started using vision models. By 2024, now you're talking about agentic AI systems. So multiple LLMs. So if an LLM or a large language model is one huge brain, one person. Agentic AI is multiple people talking to each other. In this case, multiple LLMs specialized in a particular task talking to each other. So now you're really taking off at this point. There's one more level, the 6th wave. It's physical AI. I told you that you're not going to care too much about it, at least not yet. So think of robotics. For those who've seen the Chinese New Year celebration by Unitree in 2026, you've seen the dancing robots, the acrobatic robots, the bots that were doing coordinated martial arts. Well, that's physical AI. And technically, Tesla's cars, they're classified as a bot, as a robot as well. It's physical AI. It moves around. It's not just digital. But you know what? I don't know much about physical AI, and I'm not going to talk about it. We'll just focus on the Gen AI piece and the Agentic AI piece. But I can tell you what I can talk about, what you can do to stay on the cutting edge. Basically, what can you do to stay relevant as these AI generations keep moving? Basically, a structured path like Interview Kickstart, it's a fantastic choice. You get depth instead of random tutorials. and a curriculum that builds concepts in the right order. And FANG instructors who've actually shipped real systems. So, just learning tools, you're learning how to think and build like someone who can survive the next wave, which could be quantum AI for all we know, right? Just like these folks have. Go and watch the video on your experience after you're done with this, or if you've heard enough and you want to meet the team directly, I'm going to leave a link in the description below. Now you're going to ask, why does this matter? Well, there are things that happened with the classical AI, machine learning, that still apply today. So for example, there's like 7 different machine learning problem types plus 8, which is reinforcement learning. But essentially, all machine learning problems, you can put it into one of these 7 plus 1 buckets. They are regression problems, classification problems, clustering problems, dimensionality reduction problems, anomaly detection, recommenders, or time series. And depending on what the machine learning problem is, the eval metrics, and this is what we care about, will change. So if you're dealing with regression problems, for example, you're trying to figure out voter turnout, then you'd use like an eval metric like mean error, mean squared error, mean absolute error. If you're dealing with a classification problem, let's say you're trying to classify the quality of a road. So civil engineers, they use something called PCI, Pavement Consistency Index, and so a road is classified as red, yellow, green, and you get a score. But what you really care about is the red, yellow, green, which roads need to be fixed, even if it's a Gen AI or an Agentic AI problem. And if it's classification, if it involves classification, you're still going to go back to those eval metrics. Now, in the next episode, we're going to go a little bit hands-on. We're going to focus on the Gen AI side, the LLMs, and how to handle a classification problem and how to do open coding and axial coding to figure out the quality of your model. Till then, talk to you then.